Welcome to Civil Projects of Onumoy. Today, we are taking a view on the types of foundations. The purpose of foundation is to transfer the structural load to the earth stratum. In construction, structure below ground level is called substructure, and the structure above ground level is superstructure. The objectives of foundations are to distribute load over larger area to avoid overloading of soil. These foundations are so distributed that prevent unequal settlement of structure. Foundation gives a level surface for building operation. It increases the stability of structure and prevent overturning. Foundations are broadly divided into deep and shallow foundation depending upon the bearing capacity of soil and the type of structure. Shallow foundations are further divided into three types. They are spread footing, combined footing, and mat or raft foundation. Deep foundation are of five types. They are pile foundation, under rimmed pile foundation, or bore compaction pile, pier foundation, well foundation, and caissons. Incompressible, water-logged, or made-up type of soil, where bearing capacity of soil is inadequate or steep slopes are encountered, deep foundations are provided for any type of structure. These are the types of spread footings, schematical plan and elevations shown here. A. Square footings of uniform thickness. B. Sloped square footing. C. Stepped square footing. D. Rectangular square footings of uniform thickness. E. Sloped rectangular footing. These are also the part of spread footing. They are wall footing and circular footing. A common footing provided for two or more columns in a row is known as combined footing. Need for combined footing are columns are spaced so closely that separate footing would overlap, limitations of property line, or bearing capacity of soil too low. These are the types of combined footing. They are rectangular footing and trapezoidal footing. If the footing is to support an exterior column at the property line where the projection of the footing is limited, a rectangular shape can still be used provided the interior column carries greater load. When the loading of the column is equal, rectangular shape is used with advantage. In trapezoidal footing, the greater width of the trapezium being near the heavier column where shear stress usually govern the thickness of footing slab. This is strap or cantilever footing. It is a form of combined footing wherein spread footings of two columns are connected by a beam known as strap beam. A strap footing may be adopted when the distance between two columns is so large. This is strip footing when a number of columns in a row are provided with long and narrow combined footing. It is termed as strip footing. Depending upon the center to center spacing of columns, loads on column and the bearing capacity of soil, the strip footing can be provided in the form of a slab of uniform thickness or in the form of a beam and slab type of constructions. These are The types of mat or wrapped foundation. It is as a large combined footing that covers the entire area under a building. Wrapped foundation is considered suitable when the column spacing in a structure is small and uniform and the bearing capacity of soil is low. In the different types, here showing A inverted flat slab type of uniform thickness, B inverted flat slab thickened under columns, C flat slab with pedestals under column, and D inverted slab stiffened by beams. For tall structures like silos, water storage tanks, bunkers, towers, etc., wrapped foundation is advantageously used to properly secure the structure to the ground below. This is a picture of two-way grid cellular float type wrapped foundation. Wrapped foundations are considered inhabitable for sites where large amounts of hydrostatic uplifts has to be resisted and the building has a basement. Pile foundation is under deep foundation and the types are timber, steel or concrete. Concrete may be cast in situ or precast. This is a picture of driving a precast concrete piles. In places where high compressive strength is necessary, octagonal piles with spiral laterals are generally recommended. This is a picture of under-rimmed pile foundation. Under-rimmed piles are short board cast in situ concrete piles having bulb-shaped enlargement near base. These piles are commonly recommended for providing safe and economical foundation in expensive soils such as black cotton soil, field of ground and other types of soils having poor bearing capacity. This foundation shows for a 3-storied building. This is a picture of under-rimmed pile foundation for an underground tank, and second is under-rimmed pile foundation for a retaining wall. This is a picture of under-rimmed pile foundation for a transmission tower, and second is under-rimmed pile foundation for an overhead tank. This is a picture of single under-rimmed pile and double under-rimmed pile. It is observed that structures built on expansive soils often develop severe cracks due to differential movement of ground caused by alternate sinkage and swelling with seasonal vibration. Apart from increased bearing, the enlarged pile base provides anchorage to the structure at a depth where effect of volumetric changes of soil due to seasonal vibration is negligible. The advantages of under-rimmed piles are it is structurally safe and cheaper, and the equipment used in the construction is very simple, light and easily available. They do not require highly skilled labor, by which the cost of construction becomes low. It is very suitable for loose sandy soil and where high subsoil water table. Thanks for listening. From next day, I shall discuss about various items of civil engineering. Some notes may be useful for every steps of projects. If you enjoy a little by meeting with me, then please subscribe my channel and give comments with like and share.